Hello, everyone. Thanks for joining this workshop by ETHKL. It's the first in a series of workshops that we are hoping to start. Today, the topic is Decoding Uniswap V2. For those who are not familiar with ETHKL, we are a group of Ethereum and blockchain enthusiasts. We focus on the technology and use cases, not on price. We try to host at least one meetup a month. For the last couple of years, we've been doing it online. Hopefully, in the next few months, we'll be able to do it in person when things are much more safe. And on that note, I'll pass the mic to Chichuan.
Thank you, Harif, and thank you everyone for coming. Again, my name is Chichuan from ETHKL. So today, we are trying to start a series. It's called Decoding. We are starting off Uniswap V2 because it's a commonly known protocol, and I believe that everyone should at least know Uniswap V2 in the blockchain space. If you do not know, it's a good time. Today is a good time for you to get familiar with Uniswap V2. In the future, we are looking towards decoding other things, not restricted to only protocols, possibly in the protocol layer, application layer, and so on. But it really depends. We are also open to suggestions if you have something that you would like us to take a look at, or if you like to also host one of these sessions and share your own product, feel free to. But of course, we are expecting it to be more technical. Like Harvey mentioned, we don't quite talk about price and stuff like that. The main purpose is to have this a more technical talk so that everyone is able to benefit, coders or non-coders alike. Coders will be able to read on the code and to follow to understand what's happening behind. Non-coders will be able to read the smart contract and make sure that you know what's exactly what is happening exactly in the transactions you're making to keep yourself safe. Yeah, because it's although the code is public, often people will just take it for granted and not read before they interact with the contract. So I believe that it's a skill that you must at least have. Yeah. So today, without further ado, let's start. So again, I would like to mention that if you have any questions, just leave them in the chat. I will look at them from time to time. And if I think there are a lot of people, so probably it may not be a good idea to unmute yourself and stuff like that. So yeah, without further ado, let's start. So okay, we are talking about Uniswap V2. So for the benefit of those who are not familiar, Uniswap V2 is basically a platform for you to swap tokens. What do I mean by that? So given that we have WBTC, basically Bitcoin in the Ethereum space, we are trying to swap Bitcoin. We are trying to swap Bitcoins to maybe a USDT, USD, in other words. And we are able to utilize Uniswap V2 on the Ethereum blockchain to do so, right? Traditionally, before pre-Uniswap V2, how would we do it? We would probably go to a centralized exchange. You have probably heard of Binance, Luno, and stuff like that. So this is a screenshot I have taken. It's an order book mechanism, and a typical order book will look like this, whereby the top will be the sell order, and the bottom will be the buy order. So this was taken a couple of days before. And what does it really mean? So let's take a look. So in the concept of order book, there's always a maker and taker and a spread. And a maker is basically someone who creates an order. So let's look at the sell order, for example. Hang on, someone is trying that. Yep. Let's take a look at the sell order, for example. So basically, these orders are placed by the maker, and they are like saying, saying that, hey, I would like to sell this is Ether, my Ether at so and so forth price, and I believe it's worth that much, and therefore I want to sell it at this price. And the maker for the buyer will be like, hey, I would like to buy Ether at this price, and therefore he or she creates the order. And the reason why it appears here is because no one there hasn't been some sort of like a match of price. So this is what we call spread. So in between the cheapest sell order and the most expensive buy order, there's some sort over here is a 1 cent price gap, whereby if this thing were to go a bit higher, like just 1 cent higher, this two will match, and you'll get executed, and everyone will get their order fulfilled. And if you are a taker, you basically come and say, hey, I don't care like how much I want to buy it for, I just want to buy it like now. So if you want to buy, you basically take the order away, and this is what then hence the word taker, and you'll buy 1 ETH at $3360 dollars. So earlier, to recap, there's a maker and taker and a spread. So yeah, these are fundamentals before we jump in. The traditional way of swapping tokens on a centralized exchange. And we do have a bit of problem over here. Like what happens if you want to buy like 100 ETH, for example, and you don't care about the price, but you want to get 100 ETH. And as you can see, if you sum up all the ETH over here, right, it's not 100 ETH. Basically, the price goes further up. So basically, you're buying 100 ETH not at $3360. You're getting it. You're getting 1 ETH for this amount and 0.5 for this amount, and so on and so forth. So we can see that if we are getting 100 ETH, we are getting an average price of probably higher than 3360. It could be, I don't know, 3380, depending on what we call the liquidity of the market. So yeah, and this little jump in price is what we call slippage, and slippage is something that will also happen in Uniswap V2. And but the hard thing about this is that it's really hard for you to like estimate the average price that you are getting. So this is a bit of an inconvenience. And the second thing is that you notice that there is a discrete jump between the price, because it really depends on whoever wants to make the market. So it's not like a nice like 0.01, 2, 3, and 4. It just jumps straight by 13 cents, and then jump by 1 cent, and jump by 10 cents, and so on and so forth. So yeah, it works. It sort of works, but it doesn't have these like nice properties of like continuous and slippage is hard to predict. So on to say. Yeah, let's see if I have anything that I missed out. So yep, again, the problem is that there are no like efficient manner to a pricing formula when it comes to a motherbook market order book mechanism. And if we were to do an order book mechanism in an EVM, it will be pretty expensive. It will be what we call gas inefficient, because there are a lot of like loops and matching and stuff like that needs to be going on in the code. And in EVM, that will cost you a lot of gas, or you need to pay like quite a huge sum of what we call transaction fee to do it. And yeah, so that is basically the motivation for Uniswap V2. So the original idea of a bit of history, I know it's not in the slides, but the original idea of Uniswap is by Vitalik in some ETH thesis post. So he posted this Uniswap V2 AMM model, and the first person who took it, who write it, make it to fruition, it's Hayden. From right now, I think he's the creator of the Uniswap team. So he wrote the V1 version, and so it's actually not his idea; it's actually Vitalik's idea. Yeah. So what Uniswap V2 really is? It's an I forgot to admit someone. Sorry. It's an automated market maker. Now we have seen the word maker before, right? Whereby someone makes an order. It could be a buy or sell order. So what does automated market maker really means is that Uniswap will always be the maker, and you will always be a taker. You will always be taking the orders, and whatever orders that you want your place, Uniswap will always fulfill that order. So that's so to say, and hence it's called the automated market maker, and AMM in short. And AMM is a common term that is used because automated market maker is just too long to say. Yeah, and there is this concept of liquidity provider, right? In this case, these are the liquidity providers. Like basically, you place you be the maker. Now in Uniswap V2, liquidity providers will sort of like fund the pool, so that the pool will make on behalf of the liquidity providers. So we're able to swap tokens with the liquidity providers fund, And what they get is that they get a small percentage of fee from your swap. So because they have to undertake risks associated to the price movement and so on and so forth. So yeah, they do earn something, and that's only fair. Okay, I see no questions, so let's move on. Right, so Uniswap V2 has only one very core concept, and it's only one simple mathematical concept, and this is what they call the constant product model. What it basically means is that the multiplication of x and y has to be equal to some constant k, where x it's the quantity of token x, and y will be the quantity of token y, and these two will be multiplied together, and this k to have this k constant, and this k is constant throughout the lifetime of the lifetime of the contract, so to say. So once k has been determined, everything, the price movement, everything will be fixed. Will change. I mean, these two can change, but k will never change. Yeah. Sorry, I got distracted because a lot of people are joining, and I have to let them in. All right. So this is the equation model. So this is a visual representation of how it look like. So basically, this is an inverse graph. So if you divide x and x by here, so we get y equals to 1, a k over x, and this is basically the graph that will look like. So in other words, that if a quantity of A tokens in the pool increases, the quantity of B tokens will decrease. It will move like to the right. And if the quantity of B token increases, because you're selling B means you're adding B to the pool, and therefore the quantity of it increase. The A tokens that you're buying, that means you're taking from the pool, will decrease in this direction, like up the upwards direction. So it just follows this curve, right? And okay, before we deep dive, I don't see any questions, so we will hop in. Without further ado, we'll hop into the code and to look at how things are being done in the Solidity level. Yeah, okay, I see no questions, so okay to move on. Okay, yeah, so first up, this is the repo, the GitHub repo for Uniswap V3. We are not looking at V3 today, probably sometime in the future, but these two are like the most common, the only two repos that we can look at, and it's V2 core and V2 peripheral. V2 core basically contains the core contract, like factory and pairs. I will go through that later. And peripheral is basically contracts for you to interact with factories and pairs. So I have a simple UML graph that I've created, but it's not very detailed. There is a bit of error here, whereby the arrow has to also point from router to the factory. So there is another, basically essentially another line here. But what we can understand from this is that, hey, the factory will have this create pair function that creates this contract. This contract is what we call the Uniswap V2 pair. And I do have this thing called ERC20, V2 ERC20 being wrapped on top of V2 pair. We'll see what it means later, but yeah, for now, just remember that V2 pair is also an ERC20. And ultimately, as a user, we only need to there's a spelling error here. We only need to interact through the router, and router will point our traffic to either the pair or the factory. Again, there is a line that's missing over here. Just imagine that it's there. All right. So there's only like 3 main contracts that we look at, and a couple of library contracts, which I will go into that later. Okay. Again, so everyone feel free to leave your questions in the chat. I will look at them. I'll look at them from time to time. So without further ado, let's look into the code. I will start with peripheral. Sorry, we have peripheral and we have core. I have already cloned them into my local. So this is the factory. The responsibility of the factory is to create a pair. Now, if you want to swap a token from, let's say, Ethereum to Bitcoin, we essentially need the pair to exist in the ecosystem. So if it doesn't exist, we need to create it, and people and someone need to add liquidity to it, and everyone else can trade. Yep. Can trade on it. Okay, so, and this is the pair which will be created. So let's look at how it's being created. For now, let's look at this create pair function, and what user you need to do. Again, take note that we won't be calling this function, but it's good to know because we'll be heading off to the router, which we'll call this function, and it's good to remember what is happening behind the hood. Yeah, so there are two addresses. These are token A and token B. Basically, they are the ERC20 tokens that we would like to create a pair for. At first, it will check if these two are the same, because it doesn't make sense to have the same ERC20 tokens in as a pair. It just doesn't make sense. And this line, essentially, you can see that they are ensuring that if A is less than B, and they will order in such a manner, and else it will just swap it around. What they want to do is that they want to ensure that the address that has a lower value to be a token 0 and a token 1. Well, it doesn't really matter a lot. It just helps to query the token pair later. So it saves a bit of like processes and hence a guess. And then we check to see if if the token 0 is address 0. Now, why do we do it afterwards? Because we have already ordered it. So the smaller value will always be token 0. So if this is address 0 and doesn't make sense, and then we just revert. And the next step is to check if the pair has been created. So again, if it's created, then there's no meaning in creating another similar pair. And over here, it's a bit interesting. So what it's essentially doing is that it tries to deploy the pair contract from this factory. So we're getting the creation code because we will need the creation code to basically deploy a contract. And this salt is used in create 2. So you have the creation code here, and then you have the salt, and then using create 2, you're able to deterministically create the pair of a known address. So afterwards, you initialize the pair. We'll look into initialize data and to tell the pair what tokens are being involved, and we populate. We create like a mapping over here so that we are able to find the pair address when it's given token 0 and token 1, and we do the reverse. Yeah, and then we emit an event to let people index and stuff like that. Hang on, there's a question. Okay, let me address this question. Can you go through later in order to fork a fully working Uniswap and not just front end, which repo we need to take care on? If I understand your question correctly, to fork Uniswap V2, you essentially only need the core and the peripheral. The peripheral. So these two contracts plus this one, and whatever libraries that are imported, you also need to have it. Yeah, so all these things basically you need to have those. So yeah, if you want to fork, this is how you fork, and you just deploy them to the blockchain, and then you if you want, you can verify it so that everyone can read the code, and yeah, that is pretty straightforward. Right. There's another question. Clone seems more suitable. Yeah. Basically, that is the same thing that I was addressing. Okay, moving on. So create pair. Set fee 2 is basically Uniswap team is able to set a certain fee that they want to collect. From the last time I read the docs, this has not been set yet, so we are not going to go through this in the meantime. Okay, so once the pair has been created, remember that we'll create this contract, so to say, and the first function that we'll call is this initialize function, whereby we are letting the pair know what are the tokens that form the pair that are going to be traded. So token 0, token 1. So note that this is called in the same contract call as the deployment, and therefore this one will always be correct. If you are calling it in a separate call, then people will come and probably put something in, and you'll have all sort of weird things. Yeah. So the better way, the best way is to just call this function actually in the factory, so that it will just handle everything for you, including the initialization of the pool, which is this tool. And I did mention that this is also an ERC20. So let's look at that now. So if you look at the top of the contract, there is this is thing. Is in programming is something like parent class. Its interface it's nothing. So we just look at it's inheriting from this ERC20 contract. So over here, it has standard ERC functionalities, so that why you need it, because liquidity provider will be given some sort of token as sort of like a share that they hold in the pool, so that when they withdraw, they're able to withdraw accordingly. Yeah, it will be the value, the tokens they have plus the fees that they earn. So it will all be easy for easy accounting purposes. They have this ERC20, and of course, because it's an ERC20, you can give it, you can trade it, you can transfer it into all sorts of DeFi stuff. Yeah. Okay. So right. So these are the factory creation methods. So now let's head over to the peripheral V2 peripheral to look at the router, because we essentially what we will be doing is that we won't be calling if you want to add LP or you want to create a pool, you won't be needing to call this manually. Instead, what actually you will be doing is that you will go to this V2 router, and then you will call this add liquidity function. So there are a few. There are add liquidity and add liquidity if. The difference is that if you are adding in terms of like if the native token, and hence over here is payable, and add liquidity, it means that you are adding in terms of ERC20s, like WEF, it's a wrap if, so to say, and WEF is ERC20. If it's not ERC20, you need to wrap it to WEF to make it ERC20. Yeah. So we look at this one because they are fairly similar. So what happens at first is that oh yeah, okay, before I go on, there's a question. I think the latest Ethereum, yep, we don't need a safe math in 0.8.0 because this is way older, and therefore they have to use safe math. Yeah, good point. And all right, so first thing first is that the user will need to specify like what tokens that they want to add to the pool, token A and token B, and the amount that they desire and the minimum amount they want to get from it. The address too, that means who is the liquidity provider. It could be someone else aside from you, then the token will be given to him. But normally it's yourself. And the deadline. Now deadline is important because you know, if in case your transaction got stuck there for I don't know how long, if you put like a low gas price and you have like change your mind, you said, hey, it's no longer profitable for me to add liquidity to this pool. And if your deadline is set correctly, it will fail afterwards, and your funds will be safe. If you put a too long deadline, unless you cancel the transaction, it will go in, and it may not be something that you want already. So they do have this deadline, and this modifier over here that ensures that the deadline is greater than the block timestamp. Yeah, if it's otherwise, it will fail and says that the transaction will expire. Okay, moving on. So the first internal function that you will call is okay, sorry. There's another interesting question. If you call a proxy pattern used by yourself, Uniswap doesn't use proxy pattern. Yeah, you use a create tool to directly deploy the contract. Good question. Add liquidity internal function basically helps you to calculate the amount of token you need to put in. So over here, before that, notice that I mentioned that we don't have to go through the factory to create a pair, because this _liquidity has already done it for us. So if we check that the pair doesn't exist, equals to address 0, it will create a pair for us by calling this create pair function. And if you recall earlier that we have already gone through the logic in there, and it will create the pair for us. So it's already there. Yeah, it's guaranteed to be there if you were to call this correctly. Yeah, and then you check the reserve, and there are two cases that it can happen. The first case is that when reserves are 0. So this happens when the pool is empty. Normally, when you just create a pair, and it will just directly add the amount to the pool. So now the pool will have this amount of A, this amount of B. So basically, this determines your starting price. So if you were to initialize it at a bad rate, you are giving arbitrageurs a huge opportunity to for profit. They will just arbitrage your funds away, and yeah, that's not something you want. So if you first initialize a pool, first create a pair through this liquidity function, make sure that you are giving it a amount that is sensible. Okay, and this is something that we normally will look at, because all pools are normally have funds, and yeah. So the first step is you call this library code function. Code function basically calculates how much token B that you have to put in the pool, given the token A that you want to put in. And I do have this library open, so let's look at that. Yeah, there you are. So it will do some basic checking, and over here is this is like a ratio. You can think of like amount A over amount B has to equals to amount reserve A over reserve B. So it just sort of like multiply across to get the amount B that you are supposed to put in. So with that amount B, it checks if it's lesser than the desired amount. So if it is, you'll go to this branch. If it's not, you'll go to this branch. So basically, what it really means is that can I get hang on, let me sorry for rephrase. Can I get the less than the deserved amount? It doesn't make sense. Never mind. Okay, you just go here, and then there's this required step that checks that, hey, can I get more than the minimum amount that I'm willing to get? Yeah, that makes much more sense. So if I can, I will immediately execute this one. If I cannot, then it will just say that, hey, I want too little. I want too much amount B, and if I were to add liquidity into this pair, I wouldn't get the amount that I want, so it will just fail. And yeah, and then it will just return the values that you have to add in, amount A and amount B, and this is the opposite. It will then check if this is not successful, it will check for the other branch. So these are just mirror images. And yeah, so basically what you can think of in the high level is that this internal function gives you the amount that you have to put into the liquidity pool. So if you didn't quite get all this logic, just remember that by calling this internal function with the correct parameters, you will get the amount that you should put in into the pool. So given X amount of A, you are required to put in Y amount of B, and yeah, something like that. Okay, right, no questions. And then it will then transfer to the pair X amount and amount A and amount B, and then it will mint some LP tokens to you, and this is what you will represent your liquidity. Yeah. So basically, this is how we add LP into the pool, plus create the pair if it doesn't exist. Now, one interesting thing that I have to mention is that you notice that we transfer to the pool and then we mint. So let's take a look at the mint function, because it's a bit interesting. Right, there is my call. Oops. There you go. So this is the main function. So notice that we are transferring to the pool, and then we call the main function. But in the router, it's being done in one transaction, so it's fine. But if you were to do it in separate transactions, notice that this main function it's not protected. Anyone can call it. So let's say I were to like deposit token A and token B directly into the contract without calling the main function. Like anyone can come and call this function to sort of like claim the LP for themselves. So what you essentially really want to use the router because it does everything atomically. Yeah. So yeah, this is something to take note of. And there's this lock mechanism. Basically, it's just something like a re-entrancy guard. Because some ERC20 tokens have this hook that allows a callback. You can create like a callback to this main function and do all sorts like malicious things. So that is what people call the re-entrancy attack or hack. Yeah. So this lock basically prevents that. And then one interesting thing that I have to mention that it means liquidity here, and notice that this square. No, sorry. Hang on. Let me take a look. Yeah. So when the total supply is 0, there's this very funky manner of minting liquidity, and there's this sub minimal liquidity kind of thing. And why do they have to do this very funky manner? So according to the white paper, I had to read this up also. Let me just I won't pull out the white paper. Let's try if I can try to recall. Is to sort of like mint extra token, and this extra token will be sent to the address 0, so no one has access to. Why? Because they want the total amount of liquidity to be at a higher value. So it's harder to sort of like manipulate the LP values, so on and so forth. Yeah, but that's a very high level explanation. Yeah, the white paper has a better explanation. But yeah, I just find it interesting because they have this thing here, and it got me curious. But normally, if the total supply has already, the pool has already has total supply. This is the formula that you get for the liquidity. They implement. It's not very clear here, but they implement the call it the square root of mean or something, geometric mean or something, so that the value is I would say more correct. Again, this is explained in more detail in the white paper as to why they are doing these kind of things. Yeah. And some checking, and then finally you'll just mint LP tokens to your address. So yeah. So again, for those who do not follow this logic, mint basically gives you LP token, and LP token represents your share of the pool after you have added the liquidity to the pool. Okay, that's basically half of the so the liquid mint. Okay, yeah. So the minimal liquidity is just a constant of in this case, yes. And they have a reasoning behind why this number. So for those who want to know more, the white paper is the place to go. Yep, that's correct. Right. Okay, before we move on, let's see if I have any question in the chat. No, I don't think so. Cool. Okay, so what we have essentially done is that we have covered the creation of the pair, as well as adding liquidity to the pool. What the moral of the story is to use the router, because it has done a lot of atomic work for you, so that you don't have to call separate transactions at different times, and people will take advantage of this time gap. So always use the router because it has all the logics there. Next, we'll talk about swaps, which is also an interesting feature. Again, the main function for swap is this one. It's a bit hard to read, but I'll go through it anyway because there are some interesting things that I would like to point out. So essentially what happened is that, oh yeah, okay, before I remember that there was some sort of penalty for not depositing equal amount of LP tokens. I don't know if it's a penalty or the transaction will fail. Yeah, basically, I guess it will fail. But yeah, we can try it out. Okay, so how to call this swap? This is swap function. Again, notice that it has this reentry guard. You specify the amount that you want to get, and who gets the amount and this data. It's something interesting that we'll go through later. So this amount out is a token amount that you want to get out of the pool, and it will check if there is sufficient liquidity. And if not, it will say that, hey, the pool doesn't have enough funds for you to swap. Yeah. And then, yeah, it gets the this one, token 0 and token 1, and it stores into a memory. Why they want to do that is because doing this, like, okay, so underscore token 0, it's a mem call, it's a memory call. If you're reading no underscore token 0, you're reading from the storage, and reading from the memory is cheaper than reading from the storage. So if they didn't do this step and they were to just say that, hey, everything is just like that, every token 0 call is an S load, which is more expensive, so you have to spend a bit more gas. So this is something like a caching to the memory kind of way of doing things, right? And they do a checking to see that if the tool is correct. I mean, so you don't send to the tokens, right? You don't like say that, okay, I want to swap BTC and I send back to the BTC contract itself, because that's not correct. And then now these two steps is interesting. They optimistically transfer tokens. Notice that there's no calculation involved yet, right? They just say, hey, I want 1 million Ethereum, and they will just transfer it to you. Now, why is that? This is something that Uniswap V2 has. It's what they call the flash swap. Basically, they trust that you will return you'll return the funds later on down here into the pool. And basically what it does is that it's something like flash whereby it allows you to gain a lot of funds to do all sorts of things like arbitrage and stuff like that. So traditionally, people use Aave to do a flash loan, and Aave it's not easy to use. And over here you can just like, hey, you can just say how much you want, and then they'll just give it to you. And hence this data come to play. So if you have a data specified, it will call this function, and then it will give you, and then you can execute whatever you want. Why do I say that? Because this tool could be your contract address or whatever address that you want, right? So if it's a contract address, your contract could have this function to call, and then this function has logics. So you can say that, hey, I'm taking like 1 million ETH, I'm sending over to my contract, and my contract has logics to do like other things, right? And therefore, what it really means is that Uniswap is borrowing tokens to you first without checking, all right? And at the end of the day, you need to return the balance to the contract to make sure that the math is preserved, the reserve are there and stuff like that. Everything checks out. If you do not, the entire transaction will fail, and nothing will happen. You just pay gas. So this is an interesting kind of thing whereby you can pass in data, and then you can call your own contract, and your contract can do all sorts of funky stuff. Okay. Currying function in FP, or in general used to make functions composable. Yes, something like that. Yes. And yeah, and then this is the math that sort of like check if you have returned your balance, or if you do not specify the data, you just go through this normal process whereby it gets how much you have to put in to get how much you want to put out. Yeah, basically the math, it's let me go back to the slide. The math here is a bit complicated, but let me go back to the slide so that I can explain it better. Where do you go? Yeah, there you go. So remember our constant product model, whereby x multiplied by y has to be equals to some constant k. So whatever you take out, x minus x sub 1, for example, multiplied by y plus y sub 1 has to be equals to k. So if you take out some amount of k, you have to give some amount of some amount of a, you have to give in some amount of b, so that the k constant is satisfied. So what's happening essentially in over here is that it's doing the math with some constant to make sure that it checks out. Yeah. Okay, we're running out of time, so I won't go through that in detail. And this is, yeah, make sure that it maintains the k. And this update is also an interesting thing that I would like to mention. What it means, what this update does is that it sort of like update the price zero cumulative last, and people can use that to as an oracle. It will update the last price and also update the last block, the timestamp that is last updated, and using the last price like maybe 5 blocks ago and the last price now, you can sort of like get a weighted average kind of thing. So yeah, it has a sort of like a built-in oracle. If you want to know how to like write build an oracle on top of by utilizing this cumulative last, Uniswap V2 documentation has a very good guide, but we won't go into that today. Okay, so this is the gist of swap. So again, the high-level overview is that swap. Let's see, where did it go? Yeah, swap. You give token in, you expect to get token out, and the constant product model has to be satisfied, and you can do some funky thing called flash swap in this swap function. Yeah, so that's something that if you don't understand everything, these are the things that that you only need to understand. So let's move on to the peripheral to see the router to see how it's being done. So over here, there are 4 functions essentially. It's swap exact token for token, swap tokens for exact token, swap exact ETH for tokens, and swap exact tokens for exact ETH. Like you may ask, like, what on earth are all these four functions? They're all swaps. Yeah, they're all swaps. Except that if you call X swap exact tokens for tokens, that means you're specifying that you want to swap maybe 1 ETH, and the output could be like any values that you want, right? And it's a minimum value. That's because of the slippage. And swap tokens for exact ETH tokens is that given some X amount in, you would want to get specifically how much token out from the pool. And these are equivalent. It's just that instead of giving ERC20 tokens, you are giving ETH instead. And it will do the conversion in there. So we won't go into these two because they are like similar. So why do we do this? I can foresee that, for example, in my smart contract, I would like to interact and swap tokens in Uniswap. I would like to maybe calculate exact US dollars in terms of token price. And before all this funky math, it's hard for me to like know how much I'm getting. So I'll be calling maybe $5 and I don't care how much Ether I get back. I just want to get some Ether, and then I can use the Ether to do whatever I want. And over here, it's like, I don't care how much Ether I put in. I just want to get like $5 worth of Ether. So it creates this kind of flexibility for you to interact. I find it a bit useful for smart contract developers who would like to interact with the router to have access to the pool. Yeah, so what it does is that it calculates the amount out over here, amount in over here, using the constant product model here. The constant product model. This is a constant product model. I know it's a bit fast, but it is. You can take a look later. And then it at the end it calls this swap underscore swap, which will ultimately call the swap function in each pool pair. Now I have neglected this path parameter. What is this for? This path is basically for when you are trying to swap among like many pools. So if you are only swapping between, let's say, ETH and DAI, the path will be WEF and DAI. There will need to be two addresses in the array. But if you like to swap like WEF to DAI, maybe to USDC to USDT and so forth at the end, you will specify a longer path so that the contract will know like what pools do you want to navigate through, and they'll sort accordingly. Yeah. So over here, there is this for loop that sort of gets the path, and then for each path they'll swap, get an intermediary token, and then they'll perform another swap, and so forth until you get the final output that you want. We specify as the last address of the path. So I hope that is clear. Any questions? No. Okay, awesome. All right. Okay, yeah. Is the multi? Yes, it is atomic. Yes. All transactions in blockchains are Ethereum are atomic. So if one fails, the entire thing fails. Yep, it is atomic. Okay. There's one more thing that I didn't mention. It's a burn function. Burn function is basically the remove liquidity. So once you want to remove your liquidity as an LP provider, you call this burn function. You specify like how much liquidity do you want to burn, basically how much LP token you want to burn, and it will call the burn function in the pair. So here, and then it will return you with the current amount of your tokens, token 0 and token 1. Yeah. Again, this formula follows the ratio, like how much share you have, and then it follows like how much you'll get after reserve. Again, sorry, I don't have time to go through the math over here. It's slightly complicated. And I think that is about it. We do have a couple of minutes for questions. So yeah, happy to answer any questions and feedbacks if you want, if you have any. Yeah, Harif, back to you. Question about something earlier. Okay. Okay, I have the question. When a swap function is defined, there's a underscore swap function. I didn't see underscore swap function defined. Normally, conventionally, this underscore thing really means an internal function. So for those who would like to know more, what is an internal function? It is, sorry, it's not here. It is a function that is not being able to call by outsiders. It's only being able to call by functions within the contract. So wait, hang on. Let me get to the peripheral because the underscore swap is there. So the underscore swap is in here, and this underscore swap helps us to pick the path, and then you'll call the swap function in the pool pair for us. So it's sort of you can think of it like it's like a wrapper, whereby you have like you want to trade between like this pair, and then you want to trade like maybe ETH to DAI, and DAI you want to buy maybe BTC with DAI, and then you trade to DAI to BTC, and then so on and so forth. So you specify the path, and then you have this for loop to nicely call the swap function in order. So yeah. Sorry, I missed the earlier part, but what is the benefit of using a constant product model? Basically, the benefit is that I can think of is that it sort of like helps you predict how much token you're getting out of it. There is a lot of other ways of trading token, but AMM is the constant product model is basically the easiest to implement. In Uniswap V3, they have this. They're also using constant product model, but it's a bit different whereby they have this thing called like regions or ticks. Each tick will have a different liquidity concentration. But the formula in each tick is using constant product model. And in curve is something else. In balancer, it's something. It's some other model. So I think the benefit is, don't quote me on this. I think the benefit is really easy to understand and implement.
Maybe one more thing to add for why AMM constant product models is that for those of you who were around in 2017, 2018, when there was the first decentralized exchanges, it was order book, but it was very cumbersome. Every order you want to make, any kind of approval, any kind of action takes gas and has to be done manually. So that like created a lot of friction, and AMMs just made it very, very easy for people to swap. You don't have to like do like 3 or 4 transactions just to get your transaction confirmed. Yeah, so that's one of the benefits of AMMs.
Thanks, Arif. Appreciate that. I didn't know that. And it's very expensive for order book.
Yeah. Okay, so I think that's pretty much it for today, unless there are any final questions. Before people go, I would like to send out this form. Let me just copy the link. So just a feedback form for how it was today. So if you liked anything, or if you didn't like anything, or if you have any suggestions for another protocol to dive into under the decoding series, or you just want some other topic, let's say this is too advanced, or you're interested in something else, let us know in the form, and we can see if we can do a workshop for that.
Yeah. Those are basically decoding series. Basically try to cover like everything under the blockchain. Of course, I may not be the best person to explain about this, but I think later on it'll be more like a discussion. So there are things that I'm pretty sure I'm not familiar. So I definitely everyone like in this chat can always feel free to give their feedback. It's like a two-way kind of thing.
Yeah, and before Chichon answers the final question, just to as a note for everyone, like we're all learning here. Even if you've been in Ethereum for 7 years, there's always something new to learn. So anyone feel free to suggest any topics, and if you want to lead the discussion, we're happy to as well. It's a community meetup. There's no leaders here, or at least we'd like it to be. And yeah, so before we end, Chichon, I think you can answer Alex's final question, and please remember to repeat the question.
All right, sure. So Alex's question is he was wondering how to reduce slippage costs, and if you want to reduce the slippage costs, what are we looking to optimize? So slippage really relies on the liquidity in the pool. So if you have like a huge liquidity, let me get back to the slides, because the constant product model really explains everything. Where did it go? So imagine that you have this large X and large Y. Basically, large X and large Y basically means that we have a lot of liquidity. So we are swapping a sum up. It can be a big small sum, big sum, and the Y will also change like in a small manner. So that really means that the slippage is very low. But if you have a very low liquidity, like you can think of like small X and small Y, changing X the same way as we were to change it just now will cause like the Y to change in a very drastically, and hence the slippage will be very, very high. So the only way to reduce slippage is for the pool to have like a large liquidity in Uniswap V2, and hence Uniswap V3 has this thing called a concentrated liquidity, whereby at certain range some liquidity will be much higher, and therefore if you were to trade in those like concentrated range, the slippage will be significantly reduced. Yeah, and that basically that's it. Slippage is always about liquidity that they have in the pool.
All right. Thanks everyone for joining, and thanks a lot, Chichon, for sharing. If you have any other questions, feel free to go on Telegram and kind of continue the discussion there. And yeah, if you haven't answered the feedback form yet, please do. You can leave yourself anonymous. And yeah, we just want to like have a better experience for everyone.
Yeah, so the main purpose of trying to introduce Decoding series is to introduce more technical stuff. I personally learned a lot from my research of Uniswap V2. I didn't know like some of the things that it exists. And yeah, I had fun. I hope you had too.
All right. Thanks a lot, guys.
Thanks, bye. Thanks for having me.